Hi everyone, today we will learn how to make a ball trajectory. But before that, we need to understand something like LineRenderer and also multiple scene. So let's start with LineRenderer first. Basically, LineRenderer is what we will use to make an arc of the ball. So go to our ball and let's collapse all the components first. Click this button and collapse all components. Then add component, see LineRenderer. And here we see positions, which is an array that will make our arc. Then width, which is width of the line. You will see later. Color is the color of the line. Use world space. It's easier to let you see it yourself than my explanation, so let's leave it for now. And material, we will use it to display our line. Basically, that's all we need for now. Okay, start from the position. Positions is an array, so we can set the size to 10, for example. There's coordinate. I just typed 10 for you to see that it's an array. We can get it back to 2 and see this. Index 0 is 0, 0, 0. And remember, we tick the use world space, so it will align with coordinate 0, 0, 0 in our world, basically here in our camera at the center point. Let's take a look if we put coordinates in the second index. Let's say x will be 1. You can already see the coordinate here, 1, because positive, so it will go to the right. If we put -1, it will go to the left. It's simple, normal, and y also use 1. It's already creating a direction, but it's not aligned with our ball position because we're using world space, remember. If we do not tick this option, it will stick to the ball. You can see it right here. Let's say we would need to make an arc. We need to simulate the ball, get the ball position in 1 second, 2 seconds, 3 seconds, and so on. So let's say we take 5 seconds. This is just an example, okay? Let's say 5 seconds, and the arc of the ball will go up. Let's say 1.2 for x and y go to 2. And here go to 3, and is 1.3, let's say. And we can put this as 1.5 and y going back to 2. Okay, currently the value is not make sense, so you can't see the right projection. So let's make it more realistic. 2, 3, 4. As you can see, it's already making an arc, but it's not smooth enough because we're using only 5 frames. On our prediction, we will use about 50 frames, so it will become more and more smooth. And how about the color? Right here it's set to be white, but it's pink. It's because we're not using any materials, so it can't display the object. So okay, we can go to the materials, add, and remove 1, and choose the material. I will use this because we just need this one, okay? It's already using the right color. We can change it if you want. Maybe something like this. We can set the alpha. It becomes smoother, right? But I think I like it more if the opacity low at the start. Yeah, like this. And you can also set the line width. This is our start line, and this is our end line. Let's try this. why it's moving within all the coordinates? It's because we only have one point right here. If we add it right here, double click, we can set it to small. See? So you can style your own line. For this example, I will just use this size and this size, I think. Okay, just like this. Make it smaller in the end. Oh yeah, I want you to see this first. So I will make it big and see the corner vertices and uncapped vertices. If we set it as 2, it will create corner, but it's not good enough. Basically, it's making a corner for our dot. Okay. And uncapped vertices, it's only for the end of the vertices. Let's put 2. You can see it's become more smoother and more rounded. So you can make it like this. It's not a problem because my coordinate right here is not realistic. That's why it's making weird shape. But yeah, you can do this. Again, I will set the value right here like this. It's your choice. Okay, now let's take back the world space, because we will get the ball coordinates and the position will use the ball coordinate in world point. That's why it will not be a 0, 0, 0, but the position of the ball. For example, 0.01 and 1.4 right here. Okay, we are done with setting up the line, and we can set it the size as 0. Because we will produce the size using our code, not statically right here. I hope you understand the line renderer. If not, just ask in the comment section and I will try to explain it better. Now, let's take a look at multiple scene. As you can see right here, we already have sample scene. And we can add it into build settings if you haven't. So the name is sample scene. What we want is to have 2 scenes at the same time. The first one is our main scene, and the second one is our prediction scene. Basically, the prediction scene is where we want to play the ball first. Let's say we throw the ball, but we not really throw the ball. So we can look ahead where the ball position will be, and we will put that coordinate inside our line renderer. Okay, let's try our multiple scene. Again, right now we can go to the ball script first. Let's create our main scene. Let's import using Unity engine dot scene management. Remember, we need 2 scenes, so we can create it like this. Scene. Let's call it scene main, and the second one is scene prediction. Then we initialize our scene. Right here, scene main equals scene manager dot create scene. Name main scene. We can create scene, but we can't use the same name as the existing one, which is sample scene. This is our first scene, and our second scene is scene prediction. Scene manager dot create scene prediction scene. Like that. Let's see what it's done. Take a look at the sample scene right here, and I will play this. Okay, you can see that it is creating 2 more scenes, which is what we created. Okay, so back to the code, and what we need more other than 2 scenes, we need the physics because we want to use the physics at the scene prediction. So we can create private scene main physics. Sorry, not scene, but physics scene 2D. Because we're using 2D. And also the same one for scene prediction. Scene prediction physics. Just like that. And we can get their physics scene. Scene main physics equals to scene main dot get physics in 2D. Same with the scene prediction. Scene prediction dot get physics in 2D. Okay. Next thing is we don't want all the physics running at the start. And why is it? Remember that we want to look ahead for the ball position in the scene prediction. So we need to disable real-time physics. That's the way we can look forward manually. Let's say we already give power about 5. And we want to see 1 second ahead where the ball position will be. That's when we start the physics. And stop again, so we can check the next position in the next second. And how to stop the physics? We can disable it globally by using physics 2D .simulation mode. Using simulation, at default, we're using fixed update. As you know, on the basic Unity, all physics simulation running at fixed update method. But here we can change it into update method and also script. Script means that we can control the physics simulation manually. We can start it manually and stop it. With this, you already know we need the script method. This way, our physics will not work. That's also true to our sample scene. Right here. Let's try throw the ball again. And I don't think it will work. Play. See, it's not working. Basically, we stop this because we need to start the physics manually on our scene prediction. Let's make it normal first. As you know, we need the fixed update method and then start the physics 2D simulation. Go to our void fixed update and check if our scene main physics is valid. We need to know that it's already valid to use. If not, then return. Then we can start the physics again using simulate. You can see the parameter here is using step. So we can start it using time.fixDeltaTime, just like normal. With this line, we can already start the game like before. See? It's good. Now we can start the prediction. If you remember, our step to get the ball to be thrown is click the mouse, drag, and then release the mouse. The prediction must be working at our drag point, right? So we know each time we drag it to somewhere, it will project our ball arc. So we need to give function to check when the mouse is hold using if input get mouse button 0 because it's left click. here we can get our current position. Let's say vector 2 drag position using get mouse position again. And here we will start using function like this too. Power is start position minus drag position. And here we can spawn our ball prediction and then calculate its position. After this, we can spawn the ball for prediction and send all the position to the line renderer that we have in the ball in the main scene. Just like I said, we will spawn the ball in the prediction scene. I don't think I ever tell that. So we must spawn the ball. We need an object. Let's create it first. Right here. Right now we just have our ball, and let's duplicate it and name it as ball prediction. And we don't want the ball prediction to have control, so we can remove this one and also remove line renderer. We will not render the line on this ball. Okay, we can keep the collider even though we are not using it right now. And let's make it as prefab. Create folder, prefabs, and send our ball prediction to prefabs because we need that to be spawned. Now we can remove this, save it, and go back to our script and create public game object ball prediction. And now we will spawn it right here. When we drag, we need to instantiate ball prediction object. Let's type game object new ball prediction equals game object dot instantiate ball prediction. And remember, we need this ball to be in our prediction scene. So let's move it using scene manager dot move object to scene. The object is our new ball prediction, and go to scene prediction. Then we can set the ball that we created, this prediction ball, in the same location as our ball in the main scene. Just use new ball prediction dot transform dot position equals current ball, which is our class, so we can use transform dot position. Now we have our ball in the prediction scene. Then we can throw the ball using the same method right here, but not physics because this is the ball that we need to throw. New ball prediction dot get component rigid body 2D add force power multiply by force and force mod force, just the same as this. When we throw the ball, it won't be thrown because, as you remember, we already disabled the physics and it's only running in the main scene. Okay, just for fun, let's try to run our physics in our prediction scene. Right here we can if in prediction physics dot is valid, also return if it's not ready, and we can start this scene prediction. Okay, let's try this and see what happened. I think it will be chaos. Let's start it. See in the left and click, drag. It's do nothing. It's because the variable ball prediction has not been assigned. Yeah, right. Let's see to our ball and the ball script, and we can add the ball prediction here. Let's try this again. Let's see. See? Chaos. Because it creates the ball every time we drag the ball. Ooh, it's quite fun actually. Okay, let's stop this. Before that, let's see our prediction scene. The ball prediction is found at the prediction scene. That's a good thing. Ooh, nice. Okay, let's stop this. Remove this because we're not need it. Okay, let's go to the important thing, which is calculate the position in the prediction scene so we can get the position to give it to our line renderer. Again, get back to here and get our line renderer in our ball. So line renderer ball line equals current ball get component line renderer. Remember, our ball has line renderer positions. We need to get that and set the size as we want. Currently, we will use only 50. Just type ball line dot position count equals to, let's say, 50. Then now we can iterate 50 times to get the position ahead. For int I 0 I smaller than 50 I plus plus. Then scene prediction physics dot simulate. Again using time dot delta time. Sorry, fixed delta time I mean. And ball line dot set position. This is where we set the position for each index. So set position index I then and the factor 3 position, which is using new factor 3 new ball prediction dot transform dot position x and new ball prediction dot transform dot position y. And actually we don't care about the z, so that's it. And after that we can destroy our ball prediction. Just use destroy new ball prediction, so it will not flood our scene with balls like before. Save it and you will see it won't work well, but you can get something. See? The prediction is quite weird. And what do you think? At last, we already make a trajectory, and now we need to fix this. What happened really? It's happened because our ball collided with our new prediction ball. And to make it not collide, we need to differentiate its scene. Let's modify our scene prediction. Right here, we just need the local physics for this scene. So we can create custom parameters for this. Create scene parameters, new create scene parameters, and use local physics mode and physics 2D. With this, we can just apply the physics without loading it to the scene and give it to our scene prediction. So there's a second parameter right here on create scene. We can put our scene parameters. Okay, that's it. Let's try. Play and okay, it's working correctly, right? And you can see the prediction scene is empty. Okay, nice, right? And it's following the right course. Oh, okay, great. But we need to remove this trajectory after we throw the ball, right? Let's do that. And it's quite easy by doing set the position count to 0 at our mouse up. Just put it right here, get component LineRenderer position count equals to 0. And I think it's done. Let's see. Okay, nice. It's great. Now is the time to refactor our code. It's quite messy right now. Okay, let's see. Let's move it to its own method. Create void create scene main. And put it into this method. And I will use it as a private because there's no other class will use it. And also private void create scene prediction. Cut it. And call these two methods. At the start, create scene prediction. Move it to the bottom because we won't see it anymore, I think. Paste. We need to remove this. We do not need this anymore at all. And we can see there's duplication in dragging and release the mouse. For example, in our power method and our throw method. Okay, I think we will set this into another function first. Let's say Refactor2 get throw power. And it's using start position and end position. And Refactor2 end position. Then we can return this. Multiplied by our force. So we can remove this and change it into get throw power, start position, and end position. Actually, we can refactor it much more by removing the end position because currently we don't need it. With this, we can remove the variable of the end position. And using the get throw power on our drag here and start position, get mouse position. Remove the drag position. And we can just use the power without the force multiplier. It's also like below. We can also use this directly. Remove this power and we can change it into another function. Let's say private game object spawn ball prediction. And use this. Use this. And return new ball prediction. So we can use game object new ball prediction. Ball prediction plus spawn ball prediction. Now we can also refactor this one and this one. Create our method private void throw ball. We will use this and The parameter is rigid body 2D. Physics. Start position and get mouse position. Okay, let's try. Remove this one and throwable physics. And this one throwable new ball prediction get component 2D. Okay, let's try it first so we know it's still working well. Start. Okay. Okay, it's still running good. And our code is cleaner. But we can clean it up a little bit. Like this one is, we need to make it as variable. Let's give it a name, max trajectory iteration. Let's create the variable. We can set it as public right here, and we can edit it from the editor. Public int max trajectory, set the default value as 50. Okay, let's take a look again. I think we can move this one. Yeah, I think we can. Let's do this and let's give it a name because this is the trajectory creation. So create trajectory. Put it all right here. And what we need is game object. Let's give it game object new ball prediction. Now it's pretty clear. Yeah, basically we just need to see these two methods and it already represents all what we made. Here we can move it to above because it's not private method. Basically this one will be modified later too, but we don't need to do it now. Okay, this is quite simple already. Let's see if it still works well. Play. Okay, the trajectory is gone. I think I forgot to put the trajectory method. Yeah, right? Create trajectory and give it new ball prediction. I'm sorry, I forgot to put this. Hope it's worked well. Let's see. Nice. Now let's add more iteration. 100. Great. You can predict more. Okay, that's it for now. I think you can learn so much from this video and hope it helps you. In the next video, we will start to create our full gameplay and then apply it into Android. If you like this kind of video series, please do like and subscribe. You'll find more and more complete project tutorials later. I also have Patreon if you'd like to support me in doing more of this. I'll leave the link in the video description. Thank you for watching. See you in the next video.